Okay, so hello everyone. Welcome to the session number 5, type 3. So in type 3, mainly we are going to learn about change the order of integration. Okay, change the order of integration. That is a type 3 examples in the double integral. The main purpose of the change of order is many times this inner integral is a difficult or impossible to integrate. Okay, so whenever the inner integral is difficult or impossible to evaluate, in such a case, generally it is required to change the order, then that integration is possible. So that is the main purpose. But majority of the questions that comes in the exam where it is written change the order and integrate it. So even though the calculation becomes a little lengthy there, you have to follow it because that is a question that you have. The purpose is there actually whether you are able to change the order and you are able to integrate that. Maybe the examiner want to check, so because of that you should follow the question only. So come to the first question on the change of order. So if you observe, the question is evaluate double integral e raised to minus y upon y dx dy. Let me see the region later on. Right now if you focus on this double integral, all the examples in the type 2 we done by vertical strip, is it? So we every time we taken a vertical strip and we done the integration as a dy dx. So first we integrated with y and then x. Now to integrate this integrand with respect to y, you will observe integration of e raised to minus y upon y, and here is the list of the formulas that we have. You may think about for this double integral, some of you may thought about the by parts here. You can start with the by parts, but that by part will never end because the integral will not convert in the same integral again, or it is continuously differentiable and integrable functions. So by parts also not helps us to evaluate this integral with respect to y. So in short, I want to say you that none of the formula helps here. So only one order left here, that is a dx dy. So first you should understand why we are taking the order dx dy. So this may be possible, so that only you have to think first whether if you are able to integrate with y, you take the order dy dx, otherwise dx dy only. Now let me focus on the region. The region of integration is in the first quadrant above the line x equal to y. So if you draw this region, first of all, this x-axis and the y-axis that we have, and we have to draw the line x equal to y. So this is the line x equal to y. So we said the region is in the first quadrant only, and the above the line x equal to y. See, the region towards x-axis is below it, and towards y-axis is above it. So the region, the required region of integration is this one. This is the region of integration. In this region, we are interested to take the order dx dy now. For the order dx dy, we prefer the horizontal strip. Whenever we take horizontal strip, the order is a dx dy. Just see the left hand touches to which curve? The left hand touches to y-axis, which is x equal to 0, and the right hand touches to x equal to y. So that gives us the limits of x in the double integral. So our double integral I will become e raised to minus y upon y dx dy. That is the order we decided. Limit of x is from 0 to y, and we have to see the minimum and maximum value of y over the region. Minimum value of y is a y equal to 0 here, and it goes unbounded region is there, so it's a 0 to infinity. That about the limits. And now see, the evaluation really becomes very simple because we selected the order dx dy. As we integrate with x, e raised to minus y upon y is like a constant. Integral of dx is x, limits 0 to y dy. That's one. So if we put upper limit minus lower limit, so we get e raised to minus y upon y. This is like y minus 0, so that is y only. So y dy. So y gets cancelled here, and we left integral of e raised to minus y. Very simple formula, e raised to minus y upon minus 1. Limits are 0 to infinity. Let me put upper limit e raised to minus infinity. Remember, e raised to minus infinity is a 0, and e raised to 0 is 1. Lower limit have minus sign. This denominator is a minus, so minus minus plus. So the final answer of the integral is just 1. 1 is the answer. See the calculation. How many steps we done? 1, 2, 3. Hardly in 3 to 4 steps we got the answer because we selected the order dx dy. But if you thought about dy dx, it is impossible to evaluate. It is impossible or difficult to evaluate, we can say. So this is the use of the order of integration. So sometimes we have to carefully decide the order of integration and we should evaluate it. Now this type of a question generally not come in the exam because nowhere it is mentioned change the order. So in examination the questions come question number 17 onwards. Okay, that type of examples are generally coming in the exam. So I will show you the next question here, the example 17th, where see the question will be like this: evaluate by changing the order of integration. Now compulsory we have to change it, whether it is integrable or not integrable, we should not think on it. We have to change the order. But here the boundary of the regions are given in terms of a limit. If you observe, the limits gives us the equation. So given x equal to y is the lower limit of x, upper limit of x is x equal to 1. So x equal to y to x equal to 1. Then y equal to 0 and y equal to 1. So the region is bounded by these four straight lines. So we should draw the region of integration first to change the order. First curve is y equal to 0. Y equal to 0 is x-axis. Then x equal to y is another curve. So I draw x equal to y. Next, x equal to 1 parallel to y-axis. This is my x equal to 1. And lastly, see the x equal to y is there and x equal to 1 is there. So this point, this coordinate of these points are 1 comma 1. And y equal to 1 will pass through that one only then. So this will be y equal to 1. That's one. Now the region, we have a square, we have upper triangle, lower triangle. So we have to decide the correct region first. Obviously, the correct region is this lower triangle. This is the lower triangle. Why not upper triangle? The reason is obviously this x equal to 0 is not boundary. That y-axis is not a boundary of the region. Hence, this triangle will be the correct region. So you should decide the correct region first. In that region, yes, we can draw the strip now. We can draw see original order, see x have the variable limit, so original order is a dx dy. Now we have to make it as a dy dx, so we'll take vertical strip. So strip is vertical now, so we'll see the lower end touches to y equal to 0, upper end touches to y equal to x. And what about the minimum and maximum value of x over the region? So x varies from 0 to 1. That's one. E raised to x square, and the order now we decided is a dy dx. We decided means the question is given only, change the order. So we change the order dx dy to dy dx. So the order is not decided by this one dx dy, order is decided by limit. As x have the variable limit first, so inner integration is with respect to x. Now integration is always a simple. Come to the integration 0 to 1 as it is. Integral of e raised to x square is like a constant because we are integrating with y. Integral of dy is y. Limits are 0 to x dx. Put upper limit and the lower limit. So it's an integral 0 to 1 e raised to x square into x dx. That's we left. Which method now? See the method of integration. Almost similar integral we appeared in the type 1 where we done integral of e raised to minus x square into x dx. So the example is by substitution method. So that example also we done by substitution method. So do little side work. In the side work you can say let that x square is a t. If x square is a t, 2x dx is a dt. So integral become e raised to t dt by 2. That's the integral. So 1 by 2 is a constant as it is. Integral of e raised to t is e raised to t only. And limits, if you resubstitute the value of t, it's a 1 by 2 e raised to x square. So directly this value we can use it here for the integration as 1 by 2 e raised to x square. This is after substitution method. We are putting upper and lower limit. So 1 by 2 as constant, e raised to 1 is e, and lower limit e raised to 0 is 1. And that is the end of the question. The value of the integral is 1 by 2 times e minus 1. 1 by 2 times e minus 1. Okay. See the calculation. How many steps? 3-4 steps always. Generally, the change of order calculations are really simple. The main task is to draw the region of integration, decide the region of integration, change the position of the strip, change the order, and then integrate. So these are the steps that we have for changing the order and getting the answer. 1 by 2 e minus 1. That's the answer for the example 17. Next question, example 18, third example here. In the third example, we have to change the order for 0 to 1, x square to 2 minus x, and hence evaluate the same. Because of this question, yes, compulsory we should change the order and evaluate, even though the direct integration is possible. You can integrate directly with y first and then x, and you get the answer. Now, first thing, what is the order of integration? You'll observe the limits are in terms of x. As limits are in terms of x, so that limits are of dy. Okay, so the given order is a dy dx. Okay, already the order is a dy dx given. We have to make it as a dx dy. Okay, so first you should understand the order. The order is a dy dx because these are the limits of y first. So inner limits are of y. So dy dx is order and not by this. The order is a dy dx. We have to make it a dx dy. We'll come to that later on. But before that, the region is bounded by, the boundaries are y equal to x square because these are limit of y equal to 2 minus x equal to 0, and x equal to 1. So these are the four boundaries that we have for the region. So let me draw this. First curve y equal to x square is upper parabola. So say this is my y equal to x square. Next, we have x equal to 0 is y-axis. X equal to 0 is this y-axis. X equal to 1 parallel to y-axis. So this is my x equal to 1. But for this x equal to 1, the point of intersection with this parabola y equal to x square, y equal to x square is parabola, so 1 comma 1. Is it? Now which one we left? We left only y equal to 2 minus x. Already we discussed whenever we have to draw some general straight line, simply what we do it, we replace x by 0. If we replace x by 0 in this equation, y becomes 2. Similarly, if we put y by 0, the x will become 2. So we have a line passing through 2, 0 and 0, 2. Not only that, here is a point of intersection. We can check whether that line passed through this intersection point. If we replace x by 1 in this equation, if x is 1, y is also 1. So line will pass through 1, 1. Say here is a 2, 0, and this side may be 0, 2. Okay, so this way. So our straight line will be like this. So this is the straight line y equal to 2 minus x. Okay, y is equal to 2 minus x. So this is where we got one last boundary here. Now the region of integration is whether this or this you have to think. If you are thinking about this lower region, see this is not any of the boundary. The x-axis is y equal to 0. Y equal to 0 is not a boundary given in that four limits. So obviously the correct region of integration is this one. This is the region of integration which we have all the four boundaries there. What we do it now, we generally prefer this, our aim is to change the order. So original order is a dy dx, we have to make it as a dx dy. So let I draw here horizontal strip. Okay, I taken here horizontal strip. Left hand touches to x equal to 0, right hand touches to x equal to root y. Okay, and we have to find a minimum and maximum value of y here. The minimum value of y is a 0. The maximum value of y is this 2 here, 2. So 0 to 2 we have to drag this strip. But while dragging, you will observe up to this point. Up to this point, this upper end varies on the parabola. After that, it starts varying on the straight line. So there is a need of two strips. There is a need of two strips to cover the entire region. So this region I will say R1, and another region I will say it as R2. R1 and R2. Now our double integral will become, so whatever the double integral we are given, it is on xy dx dy on the region R1 plus double integral xy dx dy on the region R2. Okay, so that will be the splitting the region. Why we taken R1 and R2? Because one strip or the upper end of the strip is not varying on the same curve throughout dragging. From when we drag from y equal to 0 to y equal to 1, it varies on the parabola. but from 1 to 2 it varies on the straight line. So because of that, we get the limits like this. Now on the region R1, think on x first. Left hand touches to x equal to 0, right hand touches to x equal to root y. So 0 to root y, and outer limits of y are 0 to 1 on the region R1. But for the region R2, the outer limit of y will be 1 to 2, where the left hand still touches to x equal to 0 only, and the right hand touches is here x equal to 2 minus y. X equal to 2 minus y. So it's a 0 to 2 minus y xy dx dy. This is the main task. Remaining calculation is really a simple. It's very simple because just you have to do the algebraic integration. We should integrate first with x and then y. When we do the first step here, it's a 0 to 1. Integral of x is x square by 2, x square by 2, limits 0 to root y dy. And similarly here 1 to 2, x square by 2, 0 to 2 minus y dy. So the next step, I'll write this side. Now root y square means root of y square. It is just y. So it is y by 2 dy. Y by 2 dy, lower limit is 0. No need to replace. Plus integral 1 to 2 now. Here 2 minus y. My mistake. I think I forgot it. There is xy is there. So when I integrated x with, so y dy should be there. Is that y dy should be there at both the place. So this y and this y become y square by 2. Now in integral, this is a 2 minus y bracket square. So 1 by 2 is a constant, that is okay. 2 minus y bracket square means 4 minus 4y plus y square into y by 2 dy. So this integration is a straightforward. Integral of y square by 2 will be y cube by 3. Y cube by 3 limits 0 to 1 plus 1 to 2. So yes, we can integrate also here. So my mistake, it is y cube by 3 into that 2. So it is y cube by 6. Is it? This is y cube by 6. This 2 is already there. So this 1 by 2 is there. So I'll write 1 by 2 here outside. This 1 by 2. And 4y integration is 4y square by 2 means 2y square. Now minus 4y square means minus 4y cube by 3. And the last y cube, it is y4 by 4. Limits are 1 to 2. Only small thing is left. You have to replace this upper limit y by 1. So it is 1 by 6 plus 1 by 2 times. Now here 2, you should replace 2 into 4, that is 8, minus 32 by 3 plus 32 by 4, that is upper limit. For lower limit, you replace y by 1 and simplify. You should get the answer as a 3 by 8. Okay, 3 by 8 is the final answer. I will show you the calculation here, directly the final answer. So you should try it your own calculation. So this was a diagram where we take an horizontal strip as a p dash q dash, and this is the answer. 3 by 8 should be the answer there. Okay, so you should complete the remaining calculation there. Okay, we'll move to the next then. Example 19. So change the order of integration and evaluate. So this is the common question in the type 3, where first of all we should draw the region of integration. Now this is a case where the region is bounded by y equal to e raised to x. This is y equal to e raised to x, y equal to e, x equal to 0, and x equal to 1. So these are the 4 curves that we have. How to draw the exponential curve? So it is exponentially goes on increasing. So this is the exponentially increasing y equal to e raised to x. That is the first curve we drawn here. X equal to 0, y-axis. X equal to 1, parallel to y-axis. So let we assume this is x equal to 1. If this is x equal to 1, if you replace in this equation, so we get y equal to e. So it is a 1 comma e. This coordinate is 1 comma e. And the last line y equal to e will be the parallel to x-axis and passing through that point only. So this is y equal to e. Now whether this lower or upper, again it's not a lower. The reason is this is not a boundary we are given. Not only this is also not a boundary. We have this boundary y equal to e raised to x is a boundary. Yes, these three. So obviously the region of integration. This is the region of integration. In this region, see the original order, y have the variable limit. Now we have to make x as a variable. So we should take a horizontal step. So we have to make the order dx dy. Now the lower end touches or left end touches to x equal to 0 and the right end touches to x equal to, this is the x equal to log of y, because y is e raised to x, then x is log y. That's one. And now we get a double integral here, or double integral I becomes x varies from 0 to log y and y varies from, see the minimum value of y. So you'll observe the minimum value of y is here. When x is a 0, this e raised to 0 is 1. So it is a 0 comma 1. So minimum value of y is 1. So it is 1 and maximum value of y is e 1 to e dx dy upon log y. So this is the integration that we have to do it. So integral of dx is very simple. It is just integral of dx is x and dy upon log y as it is. When you put upper limit here, just upper limit, it's log y into dy upon log y. So log y gets cancelled. Integral of dy is y. Limits are 1 to e. The answer is just e minus 1. E minus 1 is the value of this integral. Check if you have any doubt. Okay, go through that. It's very simple. Main task is first write down the equation of the boundaries from the limit. These 4 boundaries are written. Then graph, draw the graph, change the position of step and evaluate it. It's a e minus 1. This one is actually a solved example from the book. So answer is like this. So already we've seen e minus 1 is the answer here. Okay, so this is the graph where horizontal strip RS we taken x equal to 0 to x equal to log y. That's one. Next question, example 20. Example 20 and 19 have the same limits. You will observe y equal to e raised to x, y equal to e, x equal to 0, x equal to 1. So the graph will be the same. This is the same graph. And change the order, limit again same. So I can come to that step here. The integral I will become, you will observe the limit of this horizontal strip is there. So x equal to 0 to log y and it is 1 to e. And integral of, okay, so we'll do that integral later on. First I will write the dx dy upon y square log y. So 1 to e as it is. Integral of dx is just x, 0 to log y, and here we left dy upon y square log y. So when you replace upper limit minus lower limit, this x log y and this log y gets cancelled. We left with integral of 1 upon y square. Integral of 1 upon y square means integral of y raised to minus 2. So minus 2 plus 1 upon minus 2 plus 1, that is 1 to e. So indirectly minus 1 by y, 1 to e. If you put upper limit minus 1 by e, lower limit has minus minus plus e raised to, or y by 1 is 1. So 1 minus 1 by e. So the answer is 1 minus 1 by e, or you can write the answer as e minus 1 upon e. Any one of that is correct. Choice is yours. A small change was there in previous and this question, otherwise the calculations are same there. That's all. So 1 minus 1 by e, that is the answer we already seen here. Think on the next now. Example 21. Change the order and evaluate. Change the order and evaluate. Again, we should draw the region of integration first. Okay. Region of integration is mainly the important. What are the boundaries now? X equal to y. Inner limit is x equal to y, x equal to a. You can't say y equal to y there. Okay. So inner limits are of x equal to y to a. Outer limits are y equal to 0 to a. So this is the given limits and we have to change the order. So if you draw these curves again, y equal to 0 is x-axis, x equal to a parallel to y-axis, x equal to y, and this point will become a comma a. So y equal to a will go from this point only. Again, this upper triangle is not the correct region because this is not a boundary. So lower triangle is only the correct region. So this is the, just like example say 16, we started the first question of type 3, we started this type of the diagram only. So previously the limit of x are variable, we have to make the limit of y to the variable. So we'll take vertical strip. So the lower end touches to y equal to 0, upper end touches to y equal to x. So the double integral will become y equal to 0 to y equal to x and outer limits 0 to a. Minimum and maximum value of x over the region. So minimum value of x is a 0 here, maximum value is a. So we should integrate now first with y. So I will say dy upon x square plus y square, and that x dx is a constant as it is. So dy dx we want. Now note here, this x is like a constant, so x square is like constant. You correlate this with the integral of 1 upon a square plus y square. If integral of a square plus y square is there, it is 1 by a tan inverse of y by a. So only that a is here x, that is a constant. X is a constant, that is for integrating to y. So 1 by x tan inverse of y by x. That's the integration, and limits are 0 to x. And here is x dx as it is. You will observe when we put upper limit. Now when we put upper limit 0 to a, we get 1 by x tan inverse of 1. Tan inverse 1, the value of tan inverse of 1 is a pi by 4 minus, now lower limit tan inverse 0 is a 0. So I will say pi by 4 minus 0, that way. We use two values. Tan, when we put upper limit, we get tan inverse 1, that is pi by 4. Tan inverse 0 is 0. If you're not able to recall these values, use a calculator. On calculator, calculate tan inverse 1. Calculator will show you 45. So calculator always gives the answer in the degree. You should write in the radian, pi by 4. So this x, main thing is here, this x gets cancelled. We left only pi there, pi by 4. So pi by 4 as it is, that is a constant. Integral of dx is x and the limits 0 to a. So the answer is pi a upon 4. Pi a by 4 is the value of this double integral. Okay. So that's the example 21. Example 21. Four more examples. Example 22 now. Change the order and evaluate. Change the order and evaluate. We'll focus on the limits first. So for the limits, see the lower, these limits are in terms of x, so that should be the limit of y. So y equal to x square upon 4a, that is the first curve. Then y equal to 2 times root ax, that is another curve. Then x equal to 0 and x equal to 4a. So that about third and fourth curve. So the first curve y equal to x square upon 4a, if you write in the standard form, it comes x square equal to 4ay, is it? And what about this curve, this second curve, y square equal to 4ax? So you'll observe x square equal to 4ay is upper parabola, while y square equal to 4x is the right hand parabola. So just draw these two parabolas. One is upper parabola. So say this x square equal to 4ay. Okay. And another is now y square equal to 4x is the right hand parabola. So I'll draw with another. So I'll take y square equal to 4x like this. This is y square equal to 4x. So x square equal to 4ay is upper, y square equal to 4x is the lower. If you solve these two equations simultaneously, okay, the first intersection will be 0 comma 0, and you will observe when we replace x is equal to, generally this is 4a, x equal to 4a. If you put x equal to 4a, so y square becomes 16a square. You will observe when x is 4a, y square becomes 16a square, and y becomes again 4a. So this point is 4a comma 4a. The coordinates are 4a comma 4a that you should check. You can solve this simultaneously if you want. What you have to do it, you have to replace the value of x as y square upon 4a in this equation and simplify. So next part that is left here, this is the region of integration. That's the region of integration. In this region, the previous y have the variable limit, we have to make x to the variable. So to get x as variable limit, we take horizontal strip now. Now see the this left hand touches to y square equal to 4x, means left hand gives you the limit for x equal to this left hand. Okay, so x equal to y square upon 4a, and the right hand touches to this x square, so x equal to root 4ay, root 4ay. That's one. So come to the calculation or integration. So the integral I will become a double integral. The limit of x is y square upon 4a, y square upon 4a to root of 4ay, root of 4ay, and the outer limits are 0 to 4a. 0 to 4a, these are the limit of x. Minimum value of x is a 0, maximum value of x is 4a, and the order is now dx dy, dx dy, because the question is change the order and eval. Now integral is very simple. The outer limits 0 to 4a as it is. Integral of dx is x, limits y square upon 4a to root 4ay. So put upper limit and lower limits 0 to a as it is. It's a square root of 4ay minus y square upon 4a dy. The next step, the integration. The integration is really simple. You will observe this root of 4a is a constant as it is. Root 4a. This is the root y raised to half. The integral of y raised to half is y raised to 3 by 2 divided by 3 by 2 minus y cube upon 4 3s are 12, 12a. Limits 0 to a. Just we have to simplify this powers. Rules of indices are important here, and we get the answer. So the next few steps I will write it with this side. Okay, where you will replace, see, this is a y is replaced by a, so a raised to 3 by 2 into a raised to half. See, root 4 is 2, that root 4 is a 2, this root 4 is a 2 first. Now a raised to half into a raised to 3 by 2, so 1 by 2 plus 3 by 2 is a 4 by 2, 4 by 2 means 4 by 2 means 2 only, so it is a just a square, but this 3 by 2 become a 2 by 3, so into 2 by 3, so 2 twos are 4, so it's a 4 by 3, it's a 4 by 3 a square. This is the simplification for upper limit here, 4 by 3 a square. Remember, in this case it is a cube now. Okay, a cube upon a, so again a square minus a square by 12, because one of the a is in the denominator, that gets cancelled. That's one. Lower limit, if you replace y by 0, it's a 0 only. So 4 by 3 a square minus a square by 12. Let me make LCM. I will multiply this numerator and denominator by 4. So 12, 12 are same denominator then. So 16 minus 1. 16 minus 1 is a 15. 15 a square by 12. So you can simplify. It's a 5 by 4a square. So the final answer is a 5 by 4a square, because you can cancel 3. 3 3 4s are 12, 3 5s are 15. So 5 by 4a square will be the answer. I will show the answer here, textbook solution. So the solution is like this. First of all, this is the diagram where we draw on y square equal to 4x and x square equal to 4ay, upper and right hand parabola. And your answer comes 16a square by 3. Somewhere we made a mistake. 16a square by 3. So where is our mistake? Just 1 minute. So here is a 16a square by 3. 32a square. Okay, bracket cube is there. 0 to 4a is a limit. What we done here? Okay, 4. Yes, my mistake is here. Can you see that mistake that I made? Just I will show you where I made a mistake. So I made a mistake here. Up to here I written the limits 0 to 4a, and I suddenly shifted to 0 to a. So that is a mistake that I made. So you should be very careful. Don't make this silly mistake. So here it should be 4a. It should be 0 to 4a. And now when you replace that 4a and simplify the indices, you will get the answer that, okay, that is the required answer. So do the correction. Don't write this part. This is not correct. Okay, this is not correct. So after this, you should do your own calculation. I will show you the correct calculation here. The correct calculations will be like this. So final limits are 0 to 4a, and when you replace here, when you replace that 4a here, this a raised to 1 by 2 is there, or previously we done it is a good, in the good way. So what we write there, root 4a into y raised to 3 by 2 is there. So 4a raised to half and 4a raised to 3 by 2. So 1 by 2 plus 3 by 2 is that way. You can go that way. So like 4a raised to half is there. This 4a raised to half. When you replace 4a here, it is a 4a raised to 3 by 2. The base is same. Power of addition of the indices, 4a raised to 4 by 4, that is 2. So that becomes a 16a square. This becomes a 16a square. Denominator 2. Denominator again a 2 comes in the numerator. 16 into 16a square becomes 32a square by 3. So that is simplification for the first term. Next term is very straightforward. 4a cube. So 4 cube. But in 4 cube, one of the 4 you can keep as 4 into 16 like this. And that a cube upon 12a. So out of that, one of the 4 goes cancel here. 4 3s are 12. 1a gets cancelled, and you will left with 16a square. So final answer is this one. 16a square by 3 is the answer. That's one. That's example 22. Example 22. Next question, example 23. Here the question is change the order and evaluate. So step number 1, we should draw the correct region first. Okay, so it is a root ax, that should be, I think we'll come to that. So the region is bounded by y equal to root ax, y equal to a, x equal to 0, and x equal to a. So these are the 4 curves that we have. So we should draw these 4 curves first. Now y equal to root x means y square equal to ax. Now if even power of y is there, symmetry is about x-axis. So y square equal to ax is right hand parabola. Y square equal to ax, in which y is equal to a is the next. Y equal to a parallel to x-axis. So say somewhere here y equal to a. x equal to 0, x equal to 0 is y-axis, so this one, and x equal to a, so if this is y equal to a, so a square equal to x, so x is a, so this point of intersection is a comma a, so x equal to a will pass from here. Now the region is bounded by x equal to a, so obviously the correct region is this one. This is the region of integration. In this region, see original y have the variable limit. We have to make x to the variable. So we'll take horizontal strip here. So x equal to 0 to x equal to y square upon 4a. So this end touches to x equal to, sorry, x equal to y square upon a, and the right hand touches to x equal to 0 only. So what will be the new double integral? So change of order of the double integral will be the limits of x will be from 0 to y square upon a, 0 to y square upon a, that is the inner limit, the outer limit minimum and maximum value of y, 0 to a, it's a 0 to a. Now the limit, the order become a dx dy, so y square dy is a constant, we come across dx upon root of y4 minus a square x square, and that y square dy is as it is, that like a constant, because we are going to integrate first with x. Now think why I kept this formula, this prerequisite formula. You have to think which formula will be useful. First, obviously not first. So up to the first 6, no one. 7th, obviously not. Yes, in square root is there. So either 8, 9, 10th. So 10th is in the numerator. So 8 or 9. Obviously the 9th, because you'll observe it is in the form of square root of a square minus x square. This should be a constant. So obviously you'll observe y4, we are integrating with x, so y4 is like a constant. So integral of 1 upon root of a square minus x square is a sine inverse x by a, sine inverse x by a plus c. So only this formula we can convert, and we can use that formula. Just a minute, I will show you. So here is the entire calculation, and first of all, whatever the order we seen, you can observe the limits 0 to y square upon a and 0 to a. So here we have to treat like a square minus x square. So what is done here, that a square is taken common. From this, a square is taken common. If you take root, that a square common outside the square root, it becomes a only. So this 1 by is outside. Just a minute. So this 1 by is a constant. This a is taken common from this denominator. So it becomes y square by a bracket square minus. So this is now our capital A. It is just like 1 upon square root of a square minus x square. And the integral is sine inverse x by a. So this is sine inverse x. What is a in this case? X is, a is, say y square upon a, so divided by y square upon a. So this way, sine inverse x upon this capital A is y square upon a. So this denominator a goes in the numerator, so it becomes ax upon y square. This a goes in the numerator, so that becomes ax upon y square. And now we put upper limit and lower limit. When you put upper limit, you get sine inverse 1, and lower limit sine inverse 0. Sine inverse 1 is a pi by 2, while sine inverse 0 is a 0, and simple integration gives you the answer pi a square by 6. Okay, pi a square by 6. So the most important thing is here, this step, by observing this integrand and correlating with this formula, correlating with the formula 9, use that integration, do the integration, sorry. So, and that integration is the main part here. And little simplification, you should be alert, don't make silly mistakes in that calculation. Okay, so that about the example 23. I know this video is become little lengthy because there are more examples on the change of order in the textbook, and generally 1 or 2 questions generally repeat from these questions only. So just I want to show you all the questions which are solved examples, as well as those questions which are asked in the previous question paper. But almost the concept is the same, only integration formulas are important. Which formula you should use, that you should clear first, and you should continue. Now here again we have to draw the curves like y equal to x, y equal to root of 2 minus x square, y equal to 0, and y equal to 1. So this is a different curve. Now let me see what is that curve and how to draw that curve. First thing, yes, the boundaries are y equal to x, y equal to root of 2 minus x square, x equal to 0, x equal to 1. So these three curves, yes, you can easily draw it. But this curve, if you square the both side, you get y square equal to 2 minus x square. That is x square plus y square is 2. Is it? So we have to draw a circle of radius root 2. Is it? So whatever this circle is there, this circle is of radius root 2. Generally, okay, we'll come to that part later on. Right now, just I want to show you the graph. So say x square plus y square, we will say x square plus y square is equal to root 2. That is circle we drawn. X equal to 0, y axis, this is x equal to 0. Now x equal to 1. Now x equal to 1, you will observe if we put x as a 1, what is the value of y we are getting here? Okay, so before that, let me draw another curve. Y equal to x is one more curve we have to draw it. Okay, so x equal to 1, we'll draw it later on. Y equal to x, this is y equal to x. And now you'll observe this is a point. When you take x equal to y, so 2x square is equal to root 2. And you will observe the coordinates of that point are probably root 2 comma root 2, because you will say root 2 square, root uh, root 2 square is 2 plus 2. No, not correct, not correct, my mistake, my mistake. So y equal to x we drawn, we want the coordinates of this point, so we have to solve these two equations simultaneously. So if I replace here x equal to y in this equation, so we get x square plus x square is a root 2. So 2x square is a root 2. So x square is root 2 by 2. Okay, root 2 by 2. So x square is sorry, x is 1 by root 2. Is it? So x is 1 by root 2. No, x square is 1 by root 2. Is it? X square is 1 by root 2. So where is x equal to 1 line? I have to check that mainly. X equal to 1 will pass through which curve? Minus x square is there. So x square square plus y square is a 2. Which line we left? X equal to 1 only left. X equal to 1. So if x is a 1, y is a 1. So this coordinate, see, x is a 1, y is 1. If you replace 1 comma 1, 1 plus 1 is a 2 only. It is a square again there. Okay. So just we'll see the diagram. Just we'll come to the diagram. That's the thing that we'll see. Okay, y equal to x is there. This is 1 comma 1 because x square plus y square is 2. Okay, that is a mistake that we made. So actually I'm not doing the calculation. I'm not myself, I'm not alert. See, when we're not alert, we do these mistakes here. So where is we done the mistake? We done the mistake here. Uh, we done the mistake here. When I squared the both side, y square equal to 2 minus x square. So this x square plus y square is 2 only. So yes, x square plus y square is 2, not root 2. Here I made a mistake. I written root 2 here. So this is my silly mistake that I done, and hence this is not root 2. Here is 2 only. And now if we use this, so x square plus y square is 2. Just a minute. So you will get the coordinates x is 1, y is 1. So simple there. X is 1, y is 1. So x square plus y square is 2. So the coordinates of these points are 1 comma 1. So the line x equal to 1 is passing through this point, which is parallel to y axis. This is the x equal to 1. Now the region is bounded by this x equal to 1 circle, then this straight line. So which is the region, whether this triangle, this side or that side, you have to think on it. So obviously the region is this one. This is the region, because in this region you will observe x equal to 0 is a boundary. First of all, y equal to x is also the boundary, circle is also the boundary this side, and x equal to 1 touches to the single point there. And the original order was a dy dx. We have to make dx dy. So we'll take a horizontal strip. We take a horizontal strip here. This horizontal strip again is not enough. One strip is not enough. You'll observe the left hand touches to x equal to 0, the right hand touches to x equal to y, and up to here that strip 1 will be there, that is region 1 r1. On the r2 you have to take one more strip as a horizontal strip here, and the left hand touches to x equal to 0, while the right hand touches to x equal to square root of 2 minus y. X equal to, this is the side, x equal to root of 2 minus y. So it is a region r1 plus r2, r1 plus r2, where the limit of y will be 0 to 1, and then 1 to this value will be this value will be, so whenever say x is a 0, y is 2, so this 2 comma 0, that way. So I'll show you the diagram and the calculations here then. So here is the diagram. So you'll observe this is a 0 0, this is 1 1, this is a 0 2, coordinate of the point B are 0 to 2, and we taken a horizontal strip. So this triangle is like a region 1, and the remaining segment is the region 2, R2. So that about half of the circle is drawn. The region is, we require only the upper circle here, so that's only part is drawn here. So the order can be changed, but when we change the order, we split it into the two parts. So you'll observe this is double integral on r1. This is the r1 and this is r2 there. This is r1 and r2. So initially we have to integrate with respect to x that time. So integral of 1 upon root of a square. So when we take a horizontal strip, so the integration is with respect to x, and to get the integration, yes, which is the method we should use? What is the method we should use? That is again important thing. So to integrate this x square plus y square with respect to x, because after changing the order, the integral become like this. Double integral, will not think on the limits. Yes, we that is on the r1 and r2 have the different, but yes, we have x dx upon root of x square plus y square dy. That we have to do it after changing the order. So we are integrating with x. So how to integrate this? Just you will observe, this is the substitution method again. If we put x square plus y square as a t, x dx is a dt, because we are integrating with x, so y is like a constant. So x square plus y square is a t, 2x dx is a dt. So the integral, this inner integral become x dx is actually dt by 2, and this is 1 by root t. So 1 by 2 is a constant as it is. Integral of t raised to minus half, is t raised to minus half plus 1 upon minus half plus 1. So t raised to half divided by 1 by 2, because minus half plus 1 is plus half, this one. So this 1 by 2 gets cancelled. Actually our integration comes t raised to half. What is the t? T is x square plus y square. So x square plus y square raised to half. So this is the integration written here. Same integral x square plus y square raised to half. This is t raised to half. So this way the inner integral is done. And then the outer these limits of inner integral as per the region 1, 0 to y, and as per the, because on the region r1 x is 0 to x equal to y is coming. Okay, so that way. So this is the way you can do it. X equal to 0 to x equal to y, and then x equal to that again x equal to 0 to x equal to root of 2 minus y square, that way. These are the limits. Remaining integration and calculation, you should be able to do it. The final answer is 1 minus 1 by root 2. 1 minus 1 by root 2. That's one. Still there are two more questions, I think. Okay. Okay. So that about the question 24, example 24. Example 25, this is a completely different example. In this example, the question is just change the order, nothing else. We have to just change the order, no integration, because f of xy is not given, so we don't know f of xy, we can't integrate also. So we have to change the order. So come to the limits to change the order. So the region is bounded by, the inner limits are in terms of y, so that is x equal to 0, x equal to root of a square minus y square, y equal to minus a, and y equal to a. That's one. So if we draw this region, one of the important thing that I want to tell you in the last question only, whenever x is equal to plus square root is given, that means positive side of x only there is a curve. Suppose x equal to minus of root of a square minus y, then we can take on the negative side of x. Right now x is positive. X is positive means this side, this side x is positive, this side x is a positive, and this side x is negative. So when x is plus square root is given, so this curve we can draw it on the positive side, because when you square it, it add extra part, which is say x square equal to a square minus y square, that is x square plus y square equal to a square. So entire circle, if you can draw the entire circle also, but right now main circle we want on the right side only, positive side. So your choice, you can draw entire circle also like this. So this is the circle x square plus y square equal to a square. That is the first curve we drawn. X square plus y square equal to a square. Then x equal to 0. X equal to 0 is y axis. This one. Y equal to a. Y equal to a. This point is say a comma 0 comma a. So it is 0 comma a. So this is y equal to a. Here we have y equal to minus a. Why y equal to minus a? Because this coordinates is 0 comma minus a. 0 comma minus a. So we have the region bounded in between y equal to a to minus a, then x equal to 0, and this circle x square plus y square equal to a square. So the region of integration is this one. That's the region of integration. In this region, original limits, x have the variable limit. Now we have to make y as a variable limit, so we should take vertical strip. We take this vertical strip. Now you have to check where the lower end touches and upper end touches. You will observe the lower end and upper end touches on the same curve circle only. So how to write the limit? But remember, we write down the value of y in terms of x first. So x square plus y square is a square, means y square equal to a square minus x square, is it? So what is y? Y is taking square root on both sides. Y is the root of a square minus x square. But whenever we take a square root, we have two sign, plus or minus. And that is main task here. You will observe below x-axis, y is a negative. Y is negative. Above x-axis, y is positive. So what is this lower limit? What is lower limit? Y is equal to, lower limit is y equal to minus of root of a square minus x square. Out of that, minus root of a square minus x square is on the lower side, while upper end y is equal to plus root of a square minus x square, and that is the limit of y. That is a new limit of y. What about the limit of x? Minimum value of x is 0. The maximum value of x is here a. So that is the inner limit, and that about the double integral we want. So I will write it here also. After change of order, the inner limits are minus root of a square minus x square to plus root of a square minus x square, and it is 0 to a, and the order become f now dy dx. That's one. That is the end of a question. This is the change of order. Little tricky, but it's not difficult because the strip is varying on the same curve. So this is the new strip here, SR. The lower end touches to the as y negative, and upper end S is a y is positive there. And this is the new change of order there. This is the change of order that you should write it here, this way. Okay, any one of that, either this way or that way. Okay, so that's the example 25th. One last question on the change of order. This is one special example. It requires one special formula of integration also from the prerequisite. Nowhere we use this formula 11th formula. This 11th formula is required here because it is in that form. You'll observe integral e raised to ax into sine bx is e raised to x upon a square plus b square a sine bx minus b cos bx. That is the formula, and that formula is fitted to this integrand. So we can use this formula here. And the question is, by changing the order of integration, prove that integral of sine px upon x is 5 by 2. This is one of the standard example that comes in double integration. But yes, you can integrate this double integral by two ways. You can evaluate directly with order dx dy, and you can evaluate with order dy dx. And after doing both the way double integration, you will come to this required answer. Okay, so the hint is only you do it in the both order, integrate it from the both order there. Okay, so when you try to integrate with x here, so obviously you have to use this formula 11. Okay, formula number 11, you can use it provided you integrate with x. Okay, but when you integrate with y, everything is like a constant. Okay, every integral of dy becomes y only, and the limits are say okay, so but you can't have the same limit. You have to find out the new limit there for changing the order. Okay, so if you want to integrate with y, we should change the order. So for that, we should decide the region of integration first. What are the limits? The region is bounded by, say, x equal to 0, x equal to infinity, y0, y infinity. So the boundaries are x0, y0, x infinity, y infinity. Yes, guess what should be the region? X equal to 0. What is x equal to 0? Y axis. Y equal to 0, x axis. So x equal to 0 to infinity, y equal to 0 to infinity. So obviously the region of integration is entire positive quadrant. So this entire positive quadrant, it is unbounded region again, unbounded region. So in this region now initially we take a vertical, but if we take horizontal strip also, the limits remain same. Actually, this question I should take it in the next type here in evaluating by a polar coordinate. Let me check, because otherwise you can't integrate there. We'll come to that part. Yes, see the way that it is done. So double integral is, so we have that formula, we have that standard formula. Integral with x here, e raised to ax upon a square plus b square a sine bx plus b cos bx there, or okay, minus a sine bx minus b cos bx is there. So that formula is used and simplified. After that, we left the integral with y, so it fits the formula of tan inverse. So tan inverse y by p, and the answer comes 5 by 2 here. Okay, but if we change the order, now why there is no need of a diagram? If that limits are 0 to infinity, all limits are constant. Even though you change the order, limits remain same. So the diagram not helped us. So without diagram also you can change the order. When the limits are constant, you just interchange their order only with same limit. Okay, for constant limit you can't do it. And now the integration is done, so you're left with sine px upon x, and hence by 1 and 2, this is 1 and this is 2, by 1 and 2 we get the answer as pi by 2. Actually that integral is also possible by polar coordinates. That is also one way, but not required. Without that also it is done here. So this is the way you can remember this. One more example. So these are all possible examples of a type 3. Okay, you should go through this example, you should learn this method, you should try it your own on the paper, then only you will understand it. Okay, so that about your type 3 change of order of integration. Okay, so we'll move to the next type in the next session. Thank you. Good day. Bye.